Okay, let's complete the square on a general quadratic equation. So, completing the square on this, we'll do exactly what we did before. So the first thing is to factor out an a out of these two terms. Factor the leading coefficient out of this. So it's going to be a times x squared plus, let's see, what would I have to take a times to get b? I think I would have to take it times b over a. And I'm going to add something, and I'm going to subtract something. And I'm going to leave the constant hanging out there. Now, we're going to have a, and I'm going to have this perfect square, and it's going to be x plus half of this. So if I take b over a times a half, I get a b over 2a. So if I take half of this, I get this. And I'm supposed to put this number squared here. So that's b squared over 2a times 2a is 4a squared. And I subtract the same amount, b squared over 4a squared. So I'll have these three will make this perfect square. And I'll have minus b squared over 4a squared, and then plus c. Okay, and then to finish completing the square, we would write a times x plus b over 2a squared, and a times this, and have plus c. And then we'd combine these two. So I'll get a common denominator for these. Let's see. One of these a's will cancel. So the common denominator is 4a. So I need to multiply this one by 4a over 4a. So I get a times x plus b over 2a quantity squared. And let's see, this is negative and this is positive. So all right, minus b squared plus 4ac all over 4a. So I got minus b squared plus 4ac over 4a. And that's I completed the square. Now, the reason I'm doing this is I want to find the x-intercepts for this. And so to find the x-intercepts, I let y be 0, and I solve for x. To do that, I'll subtract this from both sides. That's the first thing, because I'm going to try to solve for x. So I'm going to subtract this, divide by a, and then take the square root and then subtract that. So I'm going to do that now. So I'm going to subtract this from both sides. So it's going to be, if I'm subtracting this, it'll be a b. I'm going to have to add b squared and subtract 4ac over 2a equals a times x plus b over 2a. I'm going to divide by a, or multiply by 1 over a. So I get b squared minus 4ac over 2. Oh, this was 4a. This is 2a, but this is 4a. This is 4a. 4a squared. A times a is a squared. And these cancel. And I get x plus b over 2a still squared. So now I'm going to take the square root of both sides. Of course, I got to do plus or minus, so I get plus or minus the square root of b squared minus 4ac over the square root of 4a squared is 2a. Square root of 4 is 2. Square root of a squared is a. Equals x plus b over 2a. And finally, if I subtract b over 2a from both sides, I get minus b over 2a plus or minus the square root of b squared minus 4ac over 2a, which you recognize, hopefully, as the quadratic formula. That's where it came from. Completing the square on the general form and then finding the x-intercepts by setting it equal to 0 and solving for x.